friends, welcome back. So today we are going to be tackling assignment 7, question 1, the Bananarama question. So the question says, in how many ways can the letters in Bananarama be arranged if the 5 A's must be together and the B and M cannot be together? All right, so as you can see, we have two parts to this question. First, the 5 A's must be together, and second, the B and M cannot be together. So we're going to tackle the 5 A's first, okay? So in order to do this, first we're going to combine all the A's into one letter. So as you can see in our original word Bananarama, we have how many A's? 1, 2, 3, 4, 5. I've underlined them all. So now instead of 5 A's, we are going to take them and I'll smush them together, combine them into one A here. So now our new word, instead of being Bananarama, it is now Bananrm. And it's 6 letters now instead of how many letters it was before, because we've condensed the 5 A's into one. Okay, so what is our next step now that we have combined all the A's into one? Well, we are going to find the number of arrangements with no restrictions with our new 6-letter word that we've made here once we've combined all the A's. So how are we going to do that? Well, let's see. Bananrm, that's a 6-letter word, like I mentioned before. So using permutations, we can do 6 factorial to find the number of ways it can be arranged. But we have to take into account, we have 2 n's here, right? The 2 n's here. Those are 2 of the same letter. So we have to take that into account. So we got to divide 6 factorial by 2 factorial to find the number of ways these letters can be arranged with no restrictions. So we work that out, 6 factorial over 2 factorial, that comes to be 360. So separating B and M, that's what we're going to tackle next. Actually though, the approach that we're going to take is we are first going to find the number of arrangements in which B and M are together, okay? And then we're going to subtract that from the no restrictions to find the number of ways in which B and M cannot be together. So let's take a look. This is our word, the 6-letter word, once the A's are combined. So we have the letters B and M. I've underlined them here. We are going to combine them into one letter. So pretend this solid yellow block is now one letter. So we have 5 letters in our word. BM, A, N, N, and R. Okay, so 5 factorial. But we have to remember that within this conglomerate block, the letters BM can be arranged in 2 ways, BM or MB, right? So 5 factorial times 2, the 2 here accounts for the 2 different ways in which they can be arranged. But then we also have to remember that we have 2 n's inside our word, right? So then our equation becomes 5 factorial times 2 over 2 factorial. And you might notice that the 2 on top and the 2 factorial on bottom, 2 factorial is just 2, right? So these 2 numbers cancel out, leaving us with 5 factorial, which is 120. So this number represents the number of arrangements in which B and M are together. Great, so now we only have one more step, which is subtraction. So to find the number of ways the letters can be arranged when B and M are not together, we can subtract the number of arrangements in which B and M are together, so from our last step, from the number of arrangements with no restrictions, the second step. So we have 360 minus 120, which is 240, and that is our final answer.